Hi, my name is Sam Cusimano, and welcome to Electricity for Progress. Today we'll be looking at a project that I've been working on with my physical computing class. Here we have an ATmega 32U4 microprocessor paired with an ESP8266 Wi-Fi board. This is a really cute and powerful board, and it allows us to have a microprocessor that could potentially be battery powered with a Wi-Fi transmitter. I'm using processing here to act as a server and receive data that's coming in from the 4 analog pins on the exposed Cactus Micro board. The program that I'm running is called Touch Glove, and it's supposed to be used with a series of pressure sensors that would be sending analog data input, which is scaled between 0 and 100. So let me show you a quick example of what we're doing here. I've decided to utilize the analog input sensors and send MIDI data. Here I'm using a control message, and I have those 4 analog sensors connected to the control channel, MIDI CC, 21, 22, 23, and 24, all on channel 1. And you can see here in the far right column the values 0 and 1 scrolling past. So when I touch these analog inputs, or otherwise use a sensor as input, we should see a reaction by the control channel here. So let's see. All right, there we go. And we get a nice smooth ramp up between values. There we go. You saw it go between here. Now we're down at 3s and 5s, and I'll squeeze again, and we get up into the 50s and 60s. You can see over here in the processing sketch, we're receiving information through IP and decoding a glove ID and the 4 variables, which are those 4 analog read pins. Besides MIDI, I'm also utilizing a robots from Java class, which allows me to send keystroke commands throughout my operating system. Now, if you see down here in the text window, when I touch the analog pins, I should be able to output some letter, there we go, the letter A, for instance, on the keypad. I've got it set up so I can hold the key down, but it's a little skittery, since of course I'm just touching the bare key, the bare circuit board. But here's the really fun part. Besides being able to transmit this information via Wi-Fi and have a MIDI hookup, which I think is really cool, I'm also now able to send those key commands into an application like Nestopia, which is a Nintendo emulator. So when I tap in here, I'm going to then start trying to press the A button, right, for the letter A that I've been passing here on the keyboard, and see if we can shoot Mega Man's blaster. Oh, cool. So I can also hold down the blaster and charge him up and fire. So this is a fun example of sending data from a microprocessor through one of these ESP8266 Wi-Fi chips, and then just receiving that through a processing sketch and decoding really basic information that's coming in, and then sending information either to MIDI information here or over to Nestopia and firing Mega Man's cannon. The goal here is to have a whole video game set up with a series of gloves where each participant is controlling one of the directions, up, down, left, right, or A, B buttons on a Nintendo controller, and as a team trying to play Mega Man. So we'll see how that interactive public electronic art can work with a large group of people. Thank you very much for tuning in to this episode of Electricity for Progress. Stay tuned for some more projects that I have on the workbench, and I'll post the code for my server and for my Arduino sketch at the links below. Cheers!